This time on Captain Chaos's Laboratory, we're going to be working on an Enesco music box, the Viva La France, and it is a very large box that is an electric music box, because they do have wind-up ones out there. So we're going to plug it in, and it relatively works, but it doesn't have motion. So this mouse is supposed to move, the balloon's supposed to spin. Power's in the back. Lights work. Kind of hard to see, but you see the light right there as an example, and then no light. So the lights work, sound works, no motion. So it's an older piece. It's from 1992, so it's 33. It is a DC 9 volt, half an amp, or 500 milliamps power supply, just so you all can see, in case you decide to buy one of the ones on eBay and it's missing its power supply, or if you have one and you lost your power supply. So let's figure out how we open this to see why there's no motion. Some of these have 2 motors. Some of them have 1 motor with a drive system off of it. So we need to figure out what style this is. This is plastic. I know a lot of folks out there are a purist when it comes to porcelain ceramic, but the original stuff, 1990s and older, they were plastic. And that's one of the things, like Mr. Christmas, everything of theirs is plastic. I know plastic is frowned upon, but you get a deeper color. It's usually more durable. So this handled the trip across the country to get here with no damage, or just a little bit of bending on the fence here, which is plastic, probably from the heat. It's more durable, it's easier to fix, so on and so forth. So I'm going to put a little pad down to relieve some of the stress off the balloon while I put it down. So on the bottom I have 1, 2, 3, 4 screws that hold the bottom on. Because of the size of this thing, I gotta move it around a little bit. Let's see. This one doesn't want to grab. Try a different screwdriver. Try this one. They're really far inside, and I think the problem is even though I have the longer bit on my electric drill, it's still touching the edge of the plastic, and I'm not getting a good bite. Rotate it, or put the balloon on the other side. There we go. I think I got them all. See which ones actually fall out of their holes. Just one. Oh. Dead battery. screws are, there we go. They're bigger than a number 1, smaller than a number 2. It's just an odd size screw. So it's just, I'm having a difficult time getting a bite to unscrew them the whole length. I mean, I got one perfectly. Now we just gotta get the others. There we go. That should be them. It's just this one screw. The rest of it's separated. The screws are stuck in their holes. Oh, one just popped out. But this one screw right here just does not want to separate. Here. There's 2. Still have this one. Yeah. So I'm going to try a different screwdriver to see if I can get a better grip. I mentioned this before. Oh, the balloon fell off. Huh, the balloon just slides into a hole. Interesting. You can sometimes use a blade screwdriver to unscrew a Phillips because you can get a better bite. That's what I'm going to try. Yeah, interesting. I would have known that. So this is like Lee Max in Department 56. This literally is keyed. If I'd have known that, I would have taken it out so it doesn't get broken. But this screw, I think the plastic that it screws into might be damaged, and it's spinning, but it's not there we go. Now it's releasing. It just didn't want to release. So all the columns are relieved except for this front column right here, and that's because there's actually glue right here on this column, and I don't know why. The rest of them have no glue. I don't know if it was alignment to hold it for the screws from the manufacturer, or if it was glued once in the past, but that is kind of strange. I'm going to see if I can just put a little bit of force on it. Like I said, I don't want to damage this because of its age. Can't get the screwdriver in there. Let's try something a little bit smaller. Let's turn this off too. So I'll show you what I'm stuck with. So right here, you kind of see that shiny? That's glue. And then turn it over. You can see there's 4 screws. 1, 2, 3, 4. And this is the column that's stuck. There's no screw. So it's kind of strange that there's just one dab of glue. It is really weird because this one moves. You can see how I have movement. And then that. Unless when they glued this on, they had it sitting sideways and the glue ran down, which is a possibility too. So I'm going to see if I can. It's a really strong glue. If you use heat, you gotta be careful because of this plastic. You don't want to distort the plastic. You don't want to damage the plastic or melt it. So I'm just going to apply a little bit of heat to see if I can get some movement. glue has gone to shiny. So I'm going to see if it'll move. That usually indicates it's starting to turn back into its liquid state. Nope. Starting to get some movement. Once it comes up, I'm not sure how much higher it'll go because of the edges of the Eiffel Tower, but I need this ring to at least pop off so I can see underneath it. It started sliding. I think I didn't heat it long enough. I actually think that when this ring comes off, some of these side panels come off because a couple of them are loose and it looks like they move up and down. Because the Eiffel Tower is screwed through the base. This disc here, not the bottom. Let's get the light back on. What I'm doing is I'm trying to score the glue, just scrape the edges of it where it was liquidy and see if that's where it's readhering. I'm not actually cutting the plastic. I'm actually using more of the backstroke than the forward stroke, so I'm using the fatter part of the blade. So what I was doing with the spudger when I had it up, I'm going to do it down now, is I was putting pressure on it. So as the glue would start to get warm, as I'm lifting, the piece would start to slide. Like that. So I'm using this as leverage to keep constant pressure on this ring. So now the ring is completely disassembled. So it's not attached anywhere. Now we're stuck on the Eiffel Tower itself. I was hoping I could slide the ring over to one side under the lips of the Eiffel Tower to get to the mechanism, or lift one of these panels out. One screw still stuck in its hole, but I'm going to move these out of the way so I don't lose them. As you can see, I have full motion on the only 4 screws that I can find to hold this thing together. just gonna spin it around and see if I see anything else. I'm going to see if the Eiffel Tower is screwed to the base or glued to the base. So we're going to do this. The Eiffel Tower is screwed to the base. I can see the screws. There are 2 screws, one on each end. At least on this pillar. I'm sure they're the same on all 4. There's the wiring. I see the gearbox. Yeah, these panels come out. Just how do they come out? That's going to be the next question. This is what I was talking about. So the panels have motion, and unless they're held in place by, it might be hard to see because it's not fully apart yet. I'm trying to do this, won't break the spire. You see that tab right there? There's one right here. That's what holds these panels centered. There's nothing really broke on this piece externally, so I don't want to glue anything together. When I put it back together, I'm not going to glue that column. I think that's from the factory when they glued this on. Now, in my day job, we have panels like this too, and the only way to take them out is you have to flex them. I don't know if these flex, but I'm going to use a small screwdriver and see how much motion I have. I have flex, but not enough. Do I have any side-to-side movement? Ooh, it's so close. Tell me your secret. How do you come apart? So I was feeling under the stickers for a hole, if there's another hidden screw. There's not. There's no. This panel might be glued on. Let's see. This panel is glued on. Maybe it's a hidden access panel. So I'm going to heat up this panel and we're going to look inside there. The other panel is cast. This panel is not. So I'm just going to heat the edges where the glue is. So you basically want to get the plastic to where it's just a hair too hot to touch. That usually allows enough flex in the glue for you to remove it. If you start seeing it change colors, meaning it gets glossy or literally changes colors, then you're getting it too hot. The edge might get glossy where the glue is, and sometimes that's just the glue turning back into a liquid. But you got to be very careful on plastic panels that you don't warp them or melt them. Alright, that panel's out. That panel doesn't do much. But you can see there's a standoff right here, which attaches to this character right here, because I'm sure he spins. He does. There's his little stud. Trying to see if maybe there's a certain point when you rotate it, it'll engage. Nope. Yeah, so this is the joys of a new piece that you've never worked on, is trying to figure out how it comes apart. Alright. So, what it looks like to me is there's a framework inside the brown, which is an external casing, just from looking through this hole. So there's a frame inside of it, and everything's built around that frame. But the only 4 screws that are visible removed, they should be coming apart. Well, at least I know the gears work, because as I rotate this, the characters are moving. So is that. I thought maybe you had to slide the characters up and then you could push it down, so we can put this guy back on. Initially when I got this piece, I thought the balloons lit up. Crazy. Yeah, so if he turns. I'll have to get that access panel later, bounced under my bench. Not a problem. Well, we're 20 plus minutes into this and I still can't figure it out. I know I'm missing something. I'm gonna go grab a brighter flashlight so I'm not using this thing that's hanging off of my other light, and that way I can move it around. Or I'm gonna get batteries for this flashlight actually. Either that one. I'm trying to figure out how this comes apart, because I'm probably gonna spend most of this video just trying to figure it out, and you guys will get bored. So give me just a second. I'm gonna go grab another light, and I'm going to see if I can figure out its trick, the key. What do I need to get this thing apart? The Enesco music boxes from the old age are tricky. I did the Pete's Dragon one. That one took me like 2 months, mainly because once I got it apart, I couldn't find the parts. They're obsolete, but I did find some. So I'm hoping this one's not the same way. The gears work. It's pretty obvious, because when I rotate this, all the characters are moving. I'm thinking the drive mechanism, which could be a gear or a belt or the motor for the animation, is bad, since the music box works and we have lights. Some of the music boxes share the one motor and it has a drive after the music box, and then some have 2 motors and the other one drives the animation. I'm thinking it's going to possibly be 2 motors, just because of the low amperage on the power supply, because one motor with that much stress will raise the amperage or the draw, and I'm thinking I do 2 to relieve the amperage draw off of 1. I could be wrong, haven't opened it yet, but we're going to see. We're going to see how they made this. I'll be back in just a moment. Okay, I am back. I got my flashlight, the other one I have that I carry with me. It does have 2 motors. I can't figure out how to get it apart, so I heated up the bows. Because they're glued on. See the glue? And then that allows you to pop these panels out. So I popped out 4. so I can see what's going on inside. And while doing it, I realized these lights don't light up. The only lights light up are down here. The lights that actually go around the Eiffel Tower don't turn on. So those light up, those don't. So we'll figure that out once we get it apart completely. So I was right, it is a dual motor as far as it's built. I'm going to rest it on my machine over there, and I'm going to zoom in so you can see the internals. And I don't know how they got this thing together, because there's screws in all different directions that don't allow you to take it apart. I'm not giving up. I'm just showing you where we're at. So that motor right there, you can see the gears, and then there's the back of the motor. I'm gonna use something thin that I can point with. That's the back of the motor. There's the gears for the motor right there. There's the drive. That's your music box. There's your circuit board for the lights. Those gears over there, that's the back of the motor that's bad. And then there's your circuit board. These light wires here are the lights that run up into the top. If I turn it on, you'll see this side over here start to move. See? If I turn it off, it stops moving. So now I'm going to rotate this 180. And let me go to a dimmer setting. There we go. Camera picks up white, and I don't know why it's now flickering, of course. There's your drive for the motor. There's your drive gear. We have chunks of crap in here, you can see right there. I cannot get the gears to turn. So I'll show you. I'm going to carefully tip this. I'm going to rotate it while I try and keep it in the zoomed in frame. If I rotate the top, you can see the gears are turning, but you notice that gear is not turning. This glob of crap, look, this is all grease. This is a gear. Here are the teeth. Doesn't turn. The gear below it does. So I think, and the motor doesn't turn at all, so I'll turn it back on. You can see here's the tip of the motor. I'm going to rotate it again, one, so you can see the motor. I'll wipe this off. So we're turning it back on. You notice that motor doesn't turn. See, no spin. So this motor, I can't even turn with a pair of pliers. It is locked up. And I think what happened is the motor was dying and it locked up, and this was rotating at full speed, which probably isn't very fast, but it's enough motion that if the motor stops abruptly, it could have cracked this gear. And I don't mean crack one of the teeth, I mean right where it attaches to this armature, right here. The problem is I still can't get this thing apart, and so we have screws that point down that hold the bottom base on. I have screws that point up that hold the top base on. And then I said, oh, maybe we can pull the center out of, meaning the whole disc will separate, because it's this, if you watch, you can see this disc is separate from this disc. So I'm like, okay, maybe we can pop this disc off and the whole top will pop off. So I rotate this thing back. This disc goes all the way through to right here, and that has a screw on the bottom going up. So this disc has a screw which holds this armature. So I have no idea how they managed to get this apart or together. So I'm thinking maybe they pressed it into the main drive gear, which the main drive gear is right back there. Where's my pointer? That's the main drive gear right here. Trying to add a little bit more light without blinding the camera. Yeah, it's a little bit more light. You can see the gear teeth all the way inside there. So I'm like, okay, I'll put a little upward pressure and rotate. Doing that, the gear is just flexing. And if that gear breaks, kind of SOL, because again, old Enesco gears are like really hard to find. I'm going to zoom back out. There we go. Good to go. So I'm like, okay, there's no screws from the top, 4 screws from the bottom. There has to be some way that they assembled this. And that is the only thing I can think of for this piece, is they literally pressed it together. And the problem is, now that it's 33 years old, I can't unpress it without potentially snapping some of the plastic. So you can see where the glue was. I just got it hot and then carefully worked it till they popped off. Just like I did on this access panel down here. This access panel just has no purpose other than you can look in at an angle and see this mount. You can kind of see my finger right there. Because it's right up against this gray is what houses the mechanism for the music. Normally they made the access panel so you can access the music box in the old days, and that's because they were serviceable. Now they're not technically serviceable. So here, this, you'll see it move, is a wiper. It's not a clip, it's not a finger. It literally, there's 4 of them. It has like felt on it, and it keeps it in the center of the ring and wipes off the debris. If it wasn't designed to wipe off the debris, they probably wouldn't put the felt on there, because there is lubrication on it. So it just spins, and then there's another one on this leg right here. I think this is the reason we lost the lights, because that's exposed wiring right there, and it's just hanging. So I'm thinking this is what caused these lights to fail. But so they don't get bound up, I'm going to push them into their slot, or a slot. I don't know if it's the slot they were designed for, but yeah, I noticed that when I took the side off, is the wires are still attached, but there's no protection, and it was just catching inside this rotating groove. Not good. So if we keep rotating, we get to this leg, there's another wiper. Now this one has no felt, so I'm thinking it either fell off or they didn't put it on all of them. And then this leg has some felt on it again. Now it looks like felt, I can't feel it, so I can't be 100% correct. And it could just be damaged plastic where it's discolored and it's soft because of the grease and the grime that's eaten into it for 33 years. So, but the only thing I can figure is this central hub has to come off, and this central hub, if you, it might be hard to see, where's the best angle again, is the gear. The gear that it looks like it's pressed onto does not turn. When I rotate this, everything rotates around the outside of that gear. That's why I'm thinking they're using that gear as a press point. The gear itself doesn't turn, the one in the center. Now that I've rotated it, it's kind of hard to see the gear. You can kind of, if you see down, I'm going to zoom back in. So that's why I'm thinking it was pressed together. The screws were to hold it tight, and they pressed it. So I'm going to zoom in as close as I can. So now you can see that big old gear all the way down in there. And then notice as I turn this, it doesn't move. See, the teeth are still pointing in the same direction. What's moving is like that gear there. That gear is riding on the outside of it. And then there's another one on the other side once we go all the way around. There's the other gear, see? Right on the outside of it. So it's a planetary gear. Planetary gear is usually pressed on or screwed on. And if it's screwed on, I have no idea how they got this thing together. Because how do you screw something that already has something screwed on top of it? But anyway, so this is definitely a conundrum. There is a trick. I don't know the trick. I'm not sure. I know on the other Enesco one I worked on, the Puff the Magic Dragon, I actually bought a parts one for like $35. I found it was broken, and I broke it apart to see how it was put together. I literally broke it, found the trick, and then I was able to fix the one that you saw in the video. This, unfortunately, the parts ones are several $100s. They're not like I can just go to this down on eBay, spend $30 or $40, get one, use it for parts in case it's got a broken gear, but I can break the thing apart to see its trick. Because I'm not going to spend $300+ on something I'm just going to shatter. Not happening. So this one I'm going to have to keep poking, prodding, testing until I find its key, or I can call around to some other companies that do repairs as far as maybe Happy Holiday Parts. I can talk with the guy there, Victor. There's one up in Canada that refers a lot of US folks down here. I can ask if he's ever seen one, because I don't want to break it. I mean, I already feel bad. I had to heat these up and break the glue off of them to get these panels out. The panels at one point were glued. You can see the residue. It's just it's so old the glue had broke free. That's why they're all loose. This was the only one that was kind of tough because this glue right here was still stuck. I just got it hot and broke the glue free. All the panels are the same. Doesn't matter where they go. The only one that's different, of course, is the one that has the power. And this one's loose too. This glue is loose because these are glued on too. When I heated up this one, the glue broke free. I'll re-glue it, not a big deal. This side the glue is still attached, that's why it only moves a little bit. But I thought maybe, okay, maybe if I unscrew these, because this has a nut and this has 2 screws, it'll come out, and that's the key. No, not even close. You can see all the wire, kinda. You can see the wires is bundled up, plenty of slack. I can take the panel out, but even if I took the panel out, I can't get a screwdriver in that little 1/8 inch gap between the circuit board or the mounting board and the wood base. So I want to show you where I'm at and what I've been doing, trying to get this thing apart. I thought, okay, maybe if I pop all the figurines off, the thing will just slide over the pins. Nope. I popped 2 of them off and realized that it's not moving. I put one back on, which was the painter. I just forgot to put this guy back on. Like that. So, taking the characters off, doesn't matter. I'm like, okay, maybe underneath the 2 pieces that don't move, there's some screws. Sure. So, but I'm not taking it apart. I just look in here and look and go, no, there is a screw, but it's not the screw for the chair. It's a screw for this, the Eiffel Tower part. The chair is literally just glued to the disc. It doesn't go through. Yeah, well, it does. There's little nubs that stick through, and you can see the little glue where they glued 3 of the 4 legs. Okay, I'm like, all right, so it's not the chair. The table's pretty obvious. There's nothing underneath it because you can see underneath the feet. Because it's one of those tables that have the 3 feet that mount like this. You can see right in the center. There. I'm like, all right, maybe this is pressed on. Well, I tried lifting it with my fingers, didn't work. So when I took the side panels off, I took a peek, looked inside, and this has big cam teeth on it, where once you line it up with the disc, you might be able to get it to lift. The problem is, when you rotate this, I can't find the notch on the disc, and I don't think it's there because it's designed to lift off. I think it's there so when the disc rotates this way, this rotates the other way. So the balloon spins the opposite direction of the rotating disc, which makes sense. It makes it look like it's moving faster, and if they're moving in the same direction, they wouldn't have a drive shaft go right up the center, because then the moon or the balloon would be spinning with it. It doesn't make sense. So it's got a cam on there so it doesn't pop out, meaning it doesn't lift because it's rotating in the wrong direction or the opposite direction. Prevents it from unscrewing itself. So I'm like, all right, so that's not going to make a big difference. Plus, I can't take the drive shaft out thinking that's what's holding it. 1, you would have to remove the top of this, and 2, the plastic it screws into, which I thought was weird, has a screw. I mean, this does rotate, because it's also just pressed on, but it doesn't come out. It doesn't do anything. But I will take it off so I don't break the spire, since I keep tipping the machine, the unit, and I don't want to break the spire off. So I'm not gonna lie, this one's got me confused. There's also, when the drive shaft goes up here into the mechanism, there's another gear set underneath this mouse, and see how it moves? So this drive shaft has to turn to make this work, and the balloon. Everything's animated. I mean, every piece of this thing's animated except for the chair and the table. So there's a lot of stuff in here. Well, the 2 chairs and the table and the easel. But anyhow, so there's my 16.5-minute long review of where I'm at, what I've done, and where I'm stuck at. And then looking at how it's made, I'm believing it's pressed together. Now my concern is, if it is pressed together, what part do I pry on, pull on, heat up, etc., to let it release the press? And then if it breaks, I have a big problem. If it doesn't break, we're golden. I can get that motor out. The motor is not screwed in. We'll rotate her all the way around again. That motor has no screws in it. What it is the base plate and the top plate have fingers, and then the motor fits through. And then on the back, it's got 2 that press the motor, so the motor's between. And then there's screws that screw the top plate and the bottom plate of the bottom section together. And then there's glue. So where the fingers are, they glued the fingers. So even when you unscrew it, you have to break those fingers to get the motor out. So it's got a... This is not the right motor, but the little fingers go over that little piece sticking out. I forgot the name of it right now, but this little outcasting. So they have the fingers going around it, and then they've glued it, and then they have the 2 flat pieces in the back. They're actually going this way, and then they glued it to the motor. So that motor's held in with pressure and glue. And I'm like, great. So I thought maybe I could wiggle the motor out and then pop a new motor in. No, can't do that because they physically glued it. So now when I try and lift or break the glue, there's a chance I might break the fingers off, because I can't do it up and down. It'd be pushing them side to side. It would be a lateral movement on a straight piece of plastic, or a vertical piece of plastic in this case, because it's up and down. So I'm like, we're not doing that, because again, I don't want to break it. And if that plastic did break, how would I get inside to repair it? Because it is repairable. If you break a finger off, you can gusset it with glue. I would use a resin glue that's a lot stronger. You can use a plastic weld, where you melt the plastic and push it back together and it welds itself. You can use a metal insert plastic welder, the type that get hot and then it melts in. And you can even use a 3D print. If you can find plastic for your 3D pen, if you have one, you can use it like a welder and leave a bead of plastic that melts into the original plastic. But you need to get the original plastic hot for that to work. So there's many ways to fix it if it does break. And I've done it to carousels that have roller guides that snap off, which is very common in Mr. Christmas. But I had access. I could remove the bottom to do it. Don't have access yet. So I'm going to pause the video and play with it some more, because from the time I paused it the first time to this section, there's probably like 30 minutes. That's how long it took me to figure out I need to get visual and start heating up the corners and pop the panels off, and then literally poking around looking for the key. And since I haven't found the key yet, I want to give you my thought process and let you know where I'm at. And might as well just take the spire off. I mean, I already pulled it off once, and I'm like, yeah, might as well just leave it off, because I don't want to break it. I don't want to break that piece off. So we're going to move it out of the way of damage. And then, of course, when I was in here watching the motion, I realized, oh, this has got extra lights. They don't work. So it's not just the motion. We only have half the lights. We have the base lights, but not the upright lights. And that could be from that wire that when I pop this panel off, I'm like, why is this wire hanging inside the mechanism? The wires don't like that. But anyway, that's where we're at. That's the update. I will pause it again and return once I either get it apart or figure out how to get it apart, and we'll go from there. And then once I get it apart, to get to the motor, I need to figure out which motor it has, because it looks like this might be the motor. It truly does, but I won't know till I get it open. I mean, it looks exactly the same. But until I get it open, I can't verify, because there's motors like this that are slightly longer, slightly shorter, slightly narrower, slightly fatter. So you have to compare the body sizes. And then voltage test. I know this is a 9 volt, and I believe this motor is up to 12 volts, and I can voltage test it. If not, I have a whole container of them right here that are rated up to well, these are only 6 volt, so they may not work. But I can also check the power going to the motor, because just because it's a 9 volt unit doesn't mean they're saying 9 volts to the motor. So, but there we go. I just couldn't read the sticker. It's yeah, 1.5 to 6 volt motor. If it is a 9 volt power, I'll get a 9 volt motor. I'll test this one, because there's no markings on this to tell me what it is. I had it out because I was working on something else that used a lot of these motors. It uses 13 of them, so I'm down to like 5, 6. So, but anyway, all right. Enough of the rambling. Back to the work. Be back in a moment. Okay, finally got it apart. Let me show you what I did. Yes, this is important. Turn this until the cams line up. You do need to remove that figure. That's why that's the easiest to come off. And then underneath that figure, we got 4 screws. And then you pop the 4 screws out. You just carefully walk it up. I didn't walk it all the way, just enough to where I got it to free move. Oh, I think one of my screws is still not all the way out. Let's see. Nope, there we go. And then bam, look at that. What a pain in the butt. Now, how I got those screws out, that you probably need a specialty tool. This is a micro flexi driver. I can bend it, so with that character out right there, I was able to bend and then turn to get those 4 screws out. Those 4 screws would hold it in. So I was using the flashlight, looking in the side, looking at these cams, going, okay, the cams are so it doesn't unscrew. No, the cams are so it doesn't unlock to get to the screws. And we got some debris in here, which is normal for its age. Very interesting pattern. And then that's the planetary gear that we saw that wasn't turning. We got resistors right here that are just wire wrapped, dangling in the middle of nowhere. No solder, no nothing. You can see the resistors through the hole. It's the weirdest assembly ever. And that's just this piece. That's not the drive. The drive for all the characters is still attached. I don't really plan on taking that part out, because that's not what the problem is. But yeah, and now you can see there's 2 screws, because there's one missing, and that's because there's nothing there. So this plate was probably used for a couple different things. We have the 97-year-old type grease where it's all brittle and nasty, so we're gonna have to clean that up. While this is apart, we'll put the panels back in, make it easier. So don't take the panels out. Like I said, I had to figure it out, and I needed to see inside. And since my x-ray specs from the 80s haven't popped up in my mail yet, I needed to make an access. And the panels were loose, so there was my access. There we go. Now we're going to lift off. I'm assuming it'll come off. Because these 2 are not screwed into anything underneath it. They're literally screw up. The motor right here is what's holding me on. The gear, sorry, not the motor. So I'm going to try and see if I can get underneath the lip and not pry onto the teeth itself, because that would be bad. Alright, what if I pry on the bottom here? So the gear, of course, is pressed on because, you know, it wouldn't turn if it wasn't. But yeah, so that's what's holding me. I hate when they do this. It's too thick. Looking for something that would put equal pressure. I really don't want to pry on the teeth. But it looks like I'm going to have to. Yeah, she's still not going to lift. Got into the basic part, but now we're stuck again. So this motor here, that is your music box. This drive here is your animated section. That was caught. Oh, okay. See these 4 holes? 4 more screws. Just barely long enough. One. Make sure you have the power off. I mean off as in unplugged, because you're right next to the power, and if you drop one of these screws into the circuit board, even though the power switch is off, there's this thing called bleed through, you might damage the circuit board. So make sure you leave it unplugged while doing this part, just for safety. Technically you're not near the circuit board over here. The circuit board's on the other side, over here. That screw is tight. Voila! Let's get the screw out. The other screw's still stuck in the plastic. So, here we go. Here's your music box. So if you were to plug this in right now, you'll see all those little fingers making the noise. What I want to do now is unscrew the motor box. Now there's not a lot of wire slack, which is a shame. I can make a little bit more by turning it because they had the wires twisted. So now I can tip this up. You can get a better look. We have a voltage regulator, which has a part number on it because it's old enough. We have some diodes. We have, well, I know why lights don't work, because the resistors are all burnt. Wow. And I bet you the motor locked up and this thing burned. So this is going to be a little bit more of a process. So I will move this more center, and I'm going to zoom in so you can get a better look at what I'm looking at. So when I had the side panel off right here, where this is resting because the panel's not there, I thought they were diodes. Diodes are black, resistors are colored, blue or tan with nice beautiful bands on them. They tell you their resistance levels. You can look them up online if you don't know by heart. So we're going to slide this over. I'm going to move this since it fell, like so. There we go. I'm going to use a pointer because my finger's going to be so fat on this engagement you won't see crap. These are resistors. This is a resistor. See how beautiful it is? Tan. We got red and brown and gold and green. Beautiful colors. You can tell what they are. Yeah, no, these are gone. And the only reason I know they're resistors is because I have magnifiers on, and I can see the burned bands because it's paint, and different color paints burn and they'll leave an imprint. So there's really slight, like you can barely see it right here. There's a little bit of a variation. That's probably this band here. I left a mark there. Also, you notice how the resistor has this beautiful cap right here where the epoxy resin, see the right there, you see how it melted back to the solder joint where it's connected to the silica or whatever they use for resistance inside. You can see it there. That one's more prominent, that one's more prominent. Yeah, those are burnt. So I bet you the motor locked up and was overamping. The resistors, which reduce the power, or reduce the amperage, got hot and they burned. And most likely these lights here, over there, on the outside of the Eiffel Tower, are on the same circuit. So these other lights aren't, and that might be why they're so dim. Because that motor is still hooked up. It's still trying to send power unless one of these is blown open, and well, we got a problem. So what does that say? Houston, we got a problem. So now I need to unscrew the circuit board and check the bottom and see if it has a logic chip that might be damaged, which in the old days it would actually be a chip that you could see and read and touch and see all the pins. And then on newer circuit boards, we have blob chips where you can't see or know what the heck it is. So I'm gonna unscrew the circuit board, and we're gonna unscrew the motor base so I can see what kind of motor it is. So very important, again, no power. Because now, even though it's only 9 volts and you're not going to electrocute yourself, you are going to blow things. Those screws out. And there's the bottom of our circuit board. It's going to be off camera for just a second while I check the tracks. You see the tracks got warm. They still look good. So this doesn't use an IC or a chip. It uses just a voltage regulator, a transistor, and 5 resistors and a potentiometer, which probably controls the voltage. So you can tune how much voltage is probably going to the lights, I would assume. Let me check. The voltage regulator controls... No, it controls the motor. My bad. So it goes over to the motor. Alright, now we'll get it back into the frame here so you're not just staring at random plastic. There we go. So there's our tracks. And those resistors that are smoked are right here. So it goes from that blob to there, that blob to there, and then this last one backwards. This blob to here, this blob to here, this blob to here. So this is the main track. As you can see, it's all one long track. So this is either the hot track or the negative track, and then this would be the opposite. See, that's all one long track. So the resistors are jumping here to here, here to here, here to here, and those are the ones that are burnt. So this track, we have the green wire at this end, and we have the voltage regulator right here, which I don't like that. If you notice, that black melted spot is right here, which goes around back to here, which then goes to the same track. I have a bad voltage regulator too. Or that could just be a dab of paint or glue. if you see this, looks like this colored stuff, that's probably from the flux, when they flux the board to solder it, and they might have got some up on here. It's not probable, but stuff happens. You never know. But anyway, but that's your voltage regulator, and the reason it sits so high is because they get hot, so it has to have airflow around it, or else it'll burn. But yeah, so our resistors go here, here, and here, 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 and here, and there's our potentiometer. So this green wire, let me see where it goes. This green wire, so there's two green wires right there. This one mode of green wire goes over here to the music box. So the music box is still getting power. The other green wire is incoming power wire. Oh, no, I am wrong again. So I'll scratch pretty much half of what I said. This is the resistor in, and it jumps, and then it jumps again. So these holes here, 1, 2, 3, it's 1, 2, 3, and 4, which was under my thumb. So the resistor is the next set of holes. This one there, this one there, this one there. See? Holes 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Why they have them in series like that, I don't know. Weird, because there's no other tracks that go off of these two to different areas, and there's nothing up here. I don't know why they just run one big resistor, because the more resistors you put in series, the higher the resistance. So if this is 10 ohms, 10 ohms, 10 ohms, now you have a 30 ohm resistor. Just put a 30 ohm resistor in. That's the way I'm looking at it. I don't see any reason why they would have done the stacking. Unless it was for heat dissipation. I don't know. If you put them in parallel, so let's say these were side by side, like these two are, and they're on the same circuit, and you had a 10 and a 10, it would be 5 ohms, because parallel cuts the power, or the resistance, and series doubles it, or they add. One adds, one divides. So that's weird. So let's figure out where this goes. I need to figure out what caused these to burn. I'm thinking it's the motor, but we don't have lights either on the thing, on the Eiffel Tower, the thing. Brain doesn't function as fast as the mouth. So we got these two right here, which is the transistor and this resistor here that's standing straight up. So this one is the one that's standing up, and this one is the third or middle leg of the transistor. And then we go over to here on this leg of the transistor. This leg goes here, and then this track goes all the way back around to the voltage regulator. So this is probably the base. There's base emitter and collector. I have to look at the number on the front. So what is attached here? We have a red wire, right? No, or yellow wire. Yellow wire. I'm using the viewfinder on the camera while I'm doing this. I'm not staring at the circuit board just to make sure I'm staying in. And the yellow wire goes back to the other motor. The motor that died has a red and a black. So the black's right there, and the red is shared. It's shared right here, which is off of the transistor. And then the black is right here. So this is definitely the negative rail right there. And just to make sure, well, this is the negative rail. My God, it's upside down, so it's hard for me to get this right. Negative, positive. Wow. So what you see in the viewfinder, when I look down, it's flipped, which is so stupid, but it is what it is. So I'm going to now unscrew the motor. I'm going to zoom the camera back out because it's that way you can see everything I'm doing. So basic electric stuff with a couple of mistakes because it's upside down. So red wire, red wire, red wire. So this red wire here is the positive. which is connected to this red wire here, which goes to the motor, and then it goes to one of the two fingers, which is for a rotor, and that rotor is right there in the middle of that planetary gear, and that's what powers these lights that don't work. So one of two things: either the motor's got such a draw it's not allowing the power to continue because the resistance is too high on the incandescent bulbs, or these three smoked resistors aren't letting power through because they're open. This screw doesn't want to cooperate. So as I'm unscrewing it, I'm lifting the plate because I think the plastic that is screwed into is either broken or stripped. This motor is nice enough to have a model number. Not all of them do, like the one I was showing you a moment ago. It doesn't have a model number. And what I thought was glue is not glue, it's just residue from everything that's on here. So I thought it was glued. It looked like it was glued. It's just this greasy crap. So this is an FF motor. It's an FF130SH. And I don't recognize the symbol. Motor feels okay. Meaning it doesn't feel chunky, crunchy, nothing. So what I'm going to do is I'm going to desolder the motor, and then I'm going to test the power going to these lights. If the motor is the problem, I don't want the motor in series. And I think it's funny that they're using the black wire as hot, since there's the hot point right there. There's a little red dot. It usually means hot. It is a reversible motor, but for general use, to make it spin in the correct direction, which is usually clockwise, they put a red dot. And I say usually clockwise because some motor manufacturers, they usually are counterclockwise. And if it spins in the wrong direction when you replace your motor because it doesn't have marks, just reverse the wires. If it's a DC motor, they'll spin the other direction. Just cleaning my tip before we get this started. So we add fresh solder to the old solder. That allows for heat transfer, so we can separate the wire. It's supposed to. The solder joint's 30 years old. Come on, there you go. There we go. And I'm going to do the same for the red, but I want to keep the two reds together because that'll send the power to the lights. Or excuse me, the fingers for the lights, because the top of the thing is not on. So there's the motor. The two red wires did come apart. So I'm going to quickly solder them back together so we can do some electrical testing next. So this turned into quite a chore. It's not just a basic repair, meaning it's just not a motor. Turned into all sorts of stuff just to get it to come apart. We can figure out what's how to do it. To hey, it burned a little bit, and now we have to deal with the burn. So I'm gonna set my my machine here for 4.5 volts DC, and I want to test this motor first. So I'm gonna put that. This motor is spinning just fine, so I'm gonna unhook it. See, it stops turning. just fine. Maybe the light shorted out, and they will and can short out. They are incandescent. LEDs can do it too, it's just not as common. So it may not have a bad motor, it may have bad lights. And then we're going to encounter another problem. So I'm going to crank this up a little bit. I'm going to go to 5 volts. I know it's a 9 volt system, but I think the voltage regulator is supposed to drop the power to them. So at 5 volts, it's drawing 0.08 of an amp. So this motor's fine. And in comparison, the replacement motor that I would have thought might fit, this thing is drawing almost a half an amp because this is not rated for 5 volts. This is a 1.5 to 3 volt motor. So now I know. You hear how it sounded like a buzzsaw or a dental drill? Yeah. That's why I like when they're marked, because you can go online and look up a sheet on this motor. It'll tell you the dimensions, the specs, the size of gear you can put on the armature, you know, because that's pretty long for a worm gear, things of that nature. Another way to test a motor, well, that's what I did first is I spun it, is if the motor is bad, they usually won't, when I let go it spins a little, they won't spin, or it'll feel like it's full of sand. Now, let's test the circuit board. You'll see this work, it'll start playing music. There is no volume control for music on this, so there's not like I can turn it down to make it quieter for the camera. There's some noises the camera picks up really loud, some it doesn't. I do know some people have been complaining about the volume on YouTube. I have no idea what is happening, but some of the creators I watch, I have to turn my computer really loud to hear them, and then the next video I watch, I almost lose my eardrums. So we thought it was maybe the camera is getting bad mic or editing software. No, I think it's YouTube with their sound suppression in their studio. Yeah, you guys really can't see that, can you? There you go. First thing I'm going to do is I want to see what this thing's putting out with the free float. So 13.75 volts. Since it's a 9 volt power supply, that's pretty decent. Let's make sure nothing is touching that's not supposed to be touching. That would be bad. Plug it in, turn it on. So under a load, .11 volts with just one motor. You gotta remember everything else is disconnected. Now, let's see if this is putting out 11 volts to the light. Now we're going to test the motor. So I'm just going to hold the wire here and then touch the wire there to see if the motor turns, because then I know my problem is the lights are drawing all the power. So probably easier to hold this one, truthfully, because there's 2 wires and they're motor turns. Look at that. Spinning right along. I like music boxes, but this one's annoying. It's actually really loud. It's really loud because the cover's off. Don't get me wrong. It's nothing to do with anything else. Okay, so we know the reason why I lost the motor. Lost the motor because we lost the lights. We lost the lights because they're probably shorted out. They're fairy lights. They're incandescent. I don't know what color they're supposed to be, so I'm going to have to go online and look up what it is. I'm sure they're a whitish color. Are they golden white, a warm white? I know they're not cold white. based on the lights down here. And these lights are rather dim, and they may be dim because we have a huge amount of power draw with a short. So, now, next, let's check this gear that wasn't turning. See why it wasn't turning. Remember, nothing was turning. And I think it's because we got a broken gear. I think it's this gear here. The one that's covered in all the goop. Yeah, I could be wrong, but we're going to find out once we get all this goop off. Yep, this gear is split. This gear has a part number on it. That is amazing. So, I just use 99% isopropyl alcohol to clean most everything because it cleans electronics, it cleans grease, it allows me to see. This gear is a TPG, right? TPG B2 24. So, it might be hard to see, but since I wiped the grease off, that dark, I'm going to zoom in. Because if I go too high, the camera loses the ability to use the lights because the lights are below the camera. The lights are not above the camera. So, focus. Focus. See the crack? See the crack? Right there and right there. And then see TPG B2 24. Very rare that you find a gear with a part number on it. Like ultra rare because they're all cheaply made. This is back when things were still quality made. Let's get some of this excess. That's the drive. That's the one that's pressed on. I don't want to break, so I'm just gonna. I'll probably get a cotton swab to clean off some of the excess. When you put it back together to re-lubricate it, just use white PTFE grease. Alright. So we're done with this part for the moment. We know that the motor's good. We know that we got a broken gear. That's why this gear is still on the shaft and it doesn't spin freely of the shaft. It's because that's supposed to be pressed on too. And I want to slide this out of here. Move these over. These are all the same screws, except for one, which is weird. The other screw is the same. And let's bring over the culprit. The reason it's here. Those resistors there look good. I don't know what those resistors are for. I'm assuming those resistors are for these lights here. So let's pull out the section that was caught and that sheared off. Ah, now I know why it's got wipers. The lights move back and forth. I don't know if you can see that right here. You go. Alright. And they're not felt. They're just covered in nasty grease. That's why the one doesn't look like it and the other ones do. It's because it's just hard, filled with dust grease. Okay, so again, I don't know why they just twisted these resistors together and they didn't actually solder them. But now we need to figure out how to take this where the wires go for this. So they run down this leg here. So here we go. There's the other end of the wire. that is, though. First thing I want to do is let me see if I can get some bare wire and we can test these lights and see if they're shorted. Because the other reason it might have blown is, all I'm doing is taking off the insulation, not cutting the wire. The other reason it may not work is it arced, and that was the reason for everything to melt, because this got caught. Oops, that was my lamp. So we have one wire coming down this column and one wire coming down this column. So let's check this side now. This side, all the wires appear to be good. We do have a piece of wire sticking off just like the other side, so they just did a horrible trim job. Alright, so I am going to assume that this wire is supposed to touch that wire. Now, these are incandescent, not LED, which means they run at a higher voltage. Probably one of the reasons why it's 9 volts. But I'm going to start at 4 volts, and I'm going to tap and see if they flicker. Because I don't really want to burn them out, because these little light bulbs are a pain to replace. In here, those you can't replace easily, you have to just replace the whole string. Since they're incandescent, they usually will work in either direction, meaning polarity of the power doesn't matter. I'm going to say the lights have a problem. I'm just going to switch to be safe. Apparently I'm not going to switch. So at 4.5 volts is pulling a huge amount of amperage, which could be because it's under voltaged. So I'm going to jump it up to 6 volts. And I'm still getting a huge amperage draw. This is probably what burned the resistors. These lights are bad. So I'm going to go up to 7. They should be on. They literally should be on. I am drawing at 7 volts, almost what that power supply is rated for. So let's go all the way up to 9. Oops, it turned on for a second. There we go. There we go. Lights are on. These lights are drawing 0.44 amps, or 4400 milliamps, or 440 milliamps, sorry. That is just under what the power supply is rated for. Power supply is rated for 500. These lights are drawing a lot of power. And that's only the ones on the wrap. The other lights and the motors, because it's got 2, you're maxing out that power supply. That's crazy. So I'm going to turn off these lights so you can get a better view. You can now see the glow. Well, you could until I knocked it off. So there's the glow. So at 9.3 volts, because I went a little high, it's pulling 0.46 volts. 0.5 volts, or excuse me, amps. 0.5 amps is what the power supply is rated for. This is literally drawing, just to run this light string, almost the entire amperage of that power supply. So that's insane. And I'm wondering if that's why they had all those resistors that smoked, was to reduce it so you could run an underpowered power supply. Or if they did it to make the light slightly dimmer so they're a light glow. Now, let's do this. Let's see what those 4 lights draw. So this white wire is connected to the same pad as the 4 lights. It's just with the other wire broke free. I don't want to start at 9. Let's drop her down. Let's start at 4.5. They might take 9 volts too. This one I might be able to clip on. Yes. Yeah, they're going to take 9 volts. So at 9 volts, the 4 up lights are pulling 0.06, and the other ones are drawing 0.44. You add the two together, you get 0.5. 0.5 is the maximum rating of the power supply. That doesn't count the motors. So I think that's the reason why they are over driving the power supply, or the power supply is getting weak. I know it's putting out the right voltage, but can it handle the amperage draw? Which you really should do in most power supplies is if you want to be at least 10% over. So in my day job, I work on high power. 240 volts is a standard, 120 sometimes. If what I'm working on pulls 42 amps, you want a 50 amp breaker, because you don't want to make the breaker hot from the power. If you're pulling 48 amps and you're on a 50 amp breaker, it's under 50 amps, that breaker will get smoking hot because it's not 10% stronger. 42 amps, 10%, makes it 47, round figures, a little higher, and that's still less than 50. So 48 amps, 10%, makes you at about 53 amps. That's more than 50. So that's how your house is rated. You never want to run your stuff at max because you will wear it out much faster. And when it comes to electricity, it causes fires, hence the 3 burnt resistors. So I'm thinking that's why everything failed. But what's confusing me is the burnt resistors are still there, and yet everything works independently. I know why lights didn't work is because the wire was sheared. Wire was sheared because it got caught in a mechanism. Don't ask me why they did it the way they did it, but they did. And it's not glued or screwed in place. It's just shoved into a hole, and well, it popped out and was spinning. And maybe that's what it's fried the resistors. It was spinning, and it got caught on one of the metal pins, especially on the other side, where it's the opposite polarity. And well, that's a dead short. Dead short is going to put that minimum half amp of power from the power supply through every component, especially the one that's shorted and anything connected to it, hence the resistors. So nothing at the moment, minus the gear, needs to be replaced, because I was going to start looking for fairy lights that are a golden glow or a warm glow, like I was going to look it up, that are probably LED, because these incandescent ones are getting harder and harder to find. They draw too much power. And then on this side, we know the motor's good. We can put the motor back in, make it turn. Well, sorry, I can't make it turn. It's got a broken gear. So I'm going to see if I can have any gear that's the same size. They're not marked. They're just generic, just like they are everything today. And see if we can get the motion. Then I'll probably end up putting her relatively back together to do a full amperage test, meaning hook everything up, put it on my machine at 9 volts DC, and then see what my machine says is pulling. Because my machine will go up to 2 amps. Continuous. At 2.5 amps it goes beep, trips. You probably heard it in other videos. That means it's too much power. This thing should draw well under 2 amps, because it's only rated for half an amp. And if it draws more than that, then we need to work on its power consumption. First things first, a gear. So yeah, this video is going to be really long. We're going to be really into this thing. So if you have this, hopefully this is going to help you. Plus I got to clean it up, get rid of this crap that we call grease, so it can get replaced with the new grease. I get these little tubes that say Super Lube, and get everything re-greased when we're done. But first things first, gear, then reassembly. I'll probably do the reassembly off camera, just for time's sake, putting the motor back in, resoldering it back on, clamping the plate back together, the whole nine. I may not reassemble this completely, but I'm going to try and get the majority of it so we can test it and then see what we're pulling. And then, well, in case you want to find the motor, there's the numbers. There you go. So that way, if you have this piece or one of the other original Enesco music boxes, they usually use this style motor. I think it's the same motor that was in the Puff the Magic Dragon. So, all right, clean off some of this grease, and then I'll be back. Okay, we're back with the Eiffel Tower here, and I've had to acquire different gear kits to find that gear. So the gear is in here. Let me get that more centered under the camera there. And you can see the gear. It's the slightly different color one on the top that's white. And because the gear is kind of not the right size, you can also see there's a green spacer right down there to keep it centered. Because when I say the right size, it's the wrong height. See how tall that is? This one's the wrong height. So, 3 different gear kits to acquire this gear. Apparently they only send one in this gear kit of 52 gears, so not a very common gear. But I've assembled it and lubricated it, and the reason I assembled it is to make sure that when all the screws are in and everything's compressed tight, it doesn't pinch the gear, that my spacer isn't too large. If the spacer's too large, it's going to pinch everything and it won't rotate. So that's why it's assembled. I had to do it twice, just so you know, because the spacer was wrong the first time. So I'm going to turn it on. You can see. So, now I did clean the gear. It doesn't look like it, but there's fresh grease on there. You can kind of see the globs where it's spun up onto the edges. But I did clean the gears. I haven't cleaned the top yet, where the track is here. I was more concerned about trying to find the right gear, because every gear that was sent was either a 0.5 millimeter too small or 0.5 millimeter too large, or it didn't have enough height, which that is, or the teeth were the wrong teeth, meaning that instead of being 18 teeth, it was 16 teeth, which means it didn't mesh correctly, or it was 30 teeth and it was too small. For the it was... So it's not a very common gear. It's from the Alkuai, or however it's pronounced, kit that I usually link in a lot of videos, especially older videos before I found Skull Crane. But I'll link it below. There is one in that kit. So if you have this piece and you buy the kit and you break the gear, because you have to press it on, you're gonna have to buy another kit. So just be aware. It's whew, it is what it is. But so the next step is get some paper towels and some alcohol, and we're going to clean the top. I am going to unplug it so that way there's no power in the circuit board, which is right here. So if any alcohol drips inside, since one of the screw holes is in the track, we don't light the thing on fire. So the alcohol is 99% isopropyl. The new alcohol I bought is 99.9%, which I'll start using when this one's empty. So you can get it on Amazon. I can link it below. It comes in a 1 gallon jug, or you can get it in 4 smaller jugs to equal 1 gallon. I used to just get it in the big 1 gallon jug, which you've seen in previous videos. I now get it in the smaller containers Matter of fact, this is the new smaller container because, well, it's smaller. It's easier to refill these little squirt bottles, and this will thread onto the top, and then you can buy straws that are longer to reach the bottom, so I can just turn this into a sprayer. Or you can just buy the whole spray head separately. A lot of places that do like potions, those essential oils sell the kits. So does Amazon. So, or if you have a little Windex bottle that's empty or something of that nature, that works too. So we're just trying to get all the old grease off the track, or as much of it as possible. And I'm going to clean up a little here because remember, it rotates kind of around this hub since we had to deal with that bush that was in the middle that hid those had those hidden screws. I don't know why there's the grease is from. Oops, I just wiped it off. I put grease on this gear. I just wiped it off. I'll put more grease on it. That's what lubricates the top of the Eiffel Tower and allows it to move all the characters. So I have no idea about the lighting as far as I've gone ahead and saw what I could do with that board, so I haven't tested it. So this is going to be the test. Those what I thought were burnt resistors. Oh, apparently I have to solder the wire back on. Let me just see if it can drive this before I worry about soldering the wires on. I'm trying to line the feet up. And the reason I say let me see if it can drive it is the motor's just free spinning. There's no resistance on it. So I want to make sure everything's moving like it's supposed to. It's still the original motor. I did not change the motor. The motor was not bad. The motor wasn't spinning because it was wedged. So what I'm having a problem with is this shaft that rotates the balloon. It's going in at an angle and it's not lining up. If it doesn't drop square in, the whole deck doesn't drop onto the top. So, but give me just a second here. I'll see if I can get this thing to snap into place. Okay, I got it. Took a few attempts, but it's on. Just got to watch those wires that aren't soldered in. I just tested it to see if it locked into place, and the wires got caught, so I just fished them out. But it should rotate again. And then that character's moving, that character's moving, and those characters are moving. So now just got to take it back apart. Which, I'm not going to lie, the part that this wedges into is really tight fit. So that square, I'll flip this over. So this is swaged. I don't know if you can see the taper. So it helps itself align, but as you push it in, it gets tighter. And yeah, it gets tight all right. So now I just need to lubricate this, solder these lights onto where they need to go, which I tucked that wire in. I must have tucked it really good because I don't see it. There it is. So we got these two wires right here that need to be taken care of. This one here, and this one here. If you remember, this one was getting drug around because that's why it's got this kink in it. It's because it had come off of whatever they had mounted it to. It's supposed to be soldered to... Oh, it gets soldered right here to this light. So and then that should connect the power to where I have lights up the entire height. So we're almost done. This has taken a couple of weeks only because I couldn't get that gear. So that gear was the bane of this job, which it's always the small cheap part. It's fine. I was running low on gear, so buying another gear kit wasn't a big deal, or in the case of this, several gear kits. But nonetheless, it's fine. I'll use them eventually, or I won't. Doesn't matter. The whole point is to fix this old Enesco piece and bring it back to life as best as we can. There we go. And I'm going to just smooth it around a little bit. That way none of the clumps fly off and get onto the circuit board. So I'm going to try and get it onto the inner and outer track, because when it turns it actually hits these outer crescent bumpers and the inner, I guess it looks more like a flower. And then I'm going to really coat these teeth. Plus I gotta glue these panels back in, or you can just set them in. Like I said, a couple were glued, a couple weren't. I think they're all glued at one point. You don't have to. That way if you want to try and pull them out while it's in, you can flex them out and look inside to see what's going on, which to me makes better sense for future repairs. You can see if the motor's died or if the gear broke or what have you, just by popping the two panels right of the power cord. So this way, and seeing, you can see everything. As you saw, there's everything right there. You can't see this motor, but then you can just pop the panel almost, well, right here. So instead of going 180 degrees, you go 160, 145 actually, I believe. But the point is, it may be worth not securing the panels fully together just for viewing access for the future, because the only thing I'm doing is putting in a new gear and hopefully making the lights work again. That motor and that motor are still original. They work. This motor was just bound up because the gear was wedged. You know, it's just one of them there things that it happens. And also, I don't know if I have the right RPM motor, but again, it tests completely fine on the machine, so we're good. So next we're going to do some soldering. So I fired up the machine, it's heating up. I'm going to unplug this so I can move it out of the way, because before I actually connect it to this, I want to connect all the power together and then use my solder station, which is with the red and black wires, because I've had a lot of questions in the last few days about these, what it's connected to. It's just a power supply solder station, so it has solder heat, and then it can do output power and test power, meaning I can test voltage coming out of something. I usually don't use that side, only because I have a meter and you can see the meter, so I can show you the numbers. But you can use a freestanding station. But what I like about them is they tell you the amperage draw. So we know by the head, the AC adapter, what the amperage draw is. And again, this one is 9 volt at a half an amp, or 500 milliamps. So if I hook this to the machine and just this top half is pulling a half an amp, then I know I have a problem with the lights, and it's going to overpower that head, and then we're going to have a problem. So, and even the standalone units have the amperage, and heck, the one I use when I work on cars, when I want to bypass the car's battery, or I just want to test one circuit without having the whole car energized, I will use one that not only has amperage and voltage, it also has wattage, which works really good when you're testing lights, because if you ever pay attention to your lights, they're rated in watts. So I don't have to sit there and do the calculation with the math equation to convert the amperage and voltage into wattage. I can have the machine do it for me. It makes it faster. Faster means more efficient. More efficient means the job gets done and it works. All right, so if I'm not mistaken, looks like this wire just connects right there. I'm gonna put a little light on the subject so I can see it better. Yeah, that's the brown wire, and the other brown wire is on this side. And that one is connected. So yeah, it's just this one right here. So technically, I don't need this much wire, but I am going to use what they have in here, and I'm going to tuck it. So I'm going to feed it around the beam before I solder it. So what I'm referring to is you see these 3 bars? I'm going to try and fish the wire behind them so it's not on the outside edge on the rotating part where it can get caught again. Now, of course, my fingers are too fat to do this, so I'm going to use some long, thin needle nose to do it, and I'm hoping this works. Also, you can use tweezers. Tweezers come in massive lengths. Now I got some like 15-inch tweezers right above, right outside the view of the camera. They actually come in pretty handy when you're trying to build a display, when you're trying to set foliage. I watched some other YouTubers about setting foliage and displays, and they were using long, thin tweezers. I usually just buy whatever the store has and use that, but now I'm trying to start doing my own displays, get inspired by some of the people out there. Alright, yeah, I think that should work pretty good. Make sure it clears that, so we're good there. So now, I just need to tin the wire. Of course, I just frayed it, so I need to straighten it. I already put flux on it, so I'm going to tin the wire. There we go. Now it's all nice equal strands. Was equal strands for some reason. There we go. Somehow I put my soldering iron through the strands, not next to the strands. Soldered together. I'm going to trim off the excess, so when the wire was cleaned up, I made it a little too long, and we don't need so much excess sticking out. That just means more stuff to get in the way. So there's the new solder joint right above my finger. That shiny thing right there that's reflecting. So now I want to make sure the lights work correctly. So I'm going to turn off the soldering iron and grab these black and red alligator clips. There it was. Bear with me, I have an important phone call. I'll be right back. Okay, sorry for that interruption. I had to take a important phone call, and we're back. So I got the meter, the power supply, not the meter, sorry. And I have it set for 9 volts. It's a 9-volt power supply. The inner track is red or hot. The outer track is negative. So if I touch them, lights. Oh, and the power consumption, that's where it concerns me, is at 0.6 amps. So we're going to put it together and see what it does. Okay, so with that being a concern, I'm going to leave this side off so I can look inside and see, make sure everything looks okay. So let's try and get this thing lined back up again. Probably the toughest part of the whole process. I thought the gear was a pain. Okay, well, it looks lined up. Now I just need the seat. There we go. Now it's seated. So, let's see if it works. So, it's not engaged. So it's seated, but it's not seated all the way, apparently. Nope, it's sitting on top of the gear. Still sitting on top of the gear. So I got the center shaft to seat, but I didn't get the gear to mesh. So what's happening is this big ring gear is sitting off center of this, so it's not. This is locking in the shaft, but it's not locking into that gear, which is lifting it so it can't touch those two metal pads to transfer the power to the lights. Oh, all right. You inside the cage? Yes. Now we gotta try and get this thing to lock in again. that's looking better. It's almost in. A little bit more to go. So I got it to where the teeth are touching, but it sits too high. Meaning that the teeth aren't meshed all the way, they're off center like that. So if you have this piece and you're doing this, be aware you're going to have alignment issues, and you're probably going to need a flashlight to see inside. This is why I want to leave those panels off. Alright, we'll see if it'll spin itself into place. There we go. Well, it's engaged. They're on the lights. Let me make sure she's seated. There's the, whoop, the lights came on for a second and turned off. All right. So we had lights for an instant and then they quit. The other lights were on though, so let's check the wiring and see if it didn't snag and break, since that's what happened the last time. Okay. One's still soldered. One's still soldered. I want to make sure that the power coming out of the unit didn't fluctuate. No. And we're going to test the lights again. The lights are working. I'm wondering if it's because it's drawing more power than this can provide, and that's my problem. I don't know if this is the original power supply or not. It might be a replacement that he sent me and it's not strong enough. I'm going to have to ask. I'm going to put it together one more time and try it. So here's what I'm finding is the problem. Could be the problem. It may have caused everything to, well, not the gear, but the discolorations. 9 volts. Power helps if on camera. 500 amps, milliamps, sorry. On my machine, this thing at 9 volts is pulling 670. 670 is a little bit larger than 5. So I'm going to try it one more time, and then I'm going to look for another power supply that's slightly stronger and see if that makes a difference. So amperage you can go up on, not down. Voltage needs to remain the same. So if I have 1,000 milliamp or 700 milliamp, I can try it and see if that changes things. And now I gotta fight with this to get it to lock back in. Of course, the center always locks in. It's the gear that doesn't want to. lubrication is important too, because if it's dry, it's got more friction, and more friction means it draws more power to do its job. Oh, put it in my pocket. You probably will need a flashlight to try and get these gears to line up. Now, if all your sides are on, you're just going to have to do it by feel. But since I have the sides off, I can see, and I can see it's not meshing. The outer ring kind of is. Wait, I think there. Yeah, it may have. Let's see. The lights are flashing. Whoa! Apparently it's not meshed. Oh, I hope it didn't break that gear, that brand new one. No, gear's still good. I think it jumped on this and was catching on this. I don't think it's sitting flush. Well, I'm going to work on it a little bit more, see what I can figure out, and let you know if I find anything specific. But I'm going to pause it for a moment while I try and figure out how to get this thing to latch all the way down and figure out why I'm not getting the power all the way up into the lights. And I'm going to look at my power supplies and see if I have a stronger one, because I think I do. If not, I'll get one of these ends and cut it off and shove it in there and put it in my machine, which can go up to 2 amps. We'll see if that works. So I'm going to do some checking. Be back in a moment. Okay, I'm back. The lights flash. That's why they weren't turning on. Also, I have my power supply plugged in, as you can see right here. This thing, when the lights are off, is drawing 0.2 amps. When the lights are on, is drawing 0.79, which still exceeds that AC adapter. But here it is. The gear that was grinding was... I'm going to turn it off for a second, because I don't know how the camera picks up, but this thing is loud, especially with the 2 panels off. Anyway, the gear that was grinding was on the top, so I have 2 screws holding this deck down, and it's keeping it centered for, yeah. So if you have this, you're going to have to screw a couple screws into it to keep it compressed so it doesn't lift and grind. Also, the other reason it's grinding is these lights move back and forth, the ones that are in the legs, and it was stuck on the track, not in the track, so it was lifted at an angle. So when it got to that point, because that gear is off to one side or offset, it lifted the gear up and over. So if you have this piece, make sure you pop these little fellas into their appropriate brackets. If not, well, you heard it. So let's see what this looks like with all its pieces in. Let's get the balloon mouse back on, like so. And now I'm going to reduce some of the lighting in here. One more. So the light in here is the ambient light through the window. Might be able to see the lights better that way. Done a few revolutions. It's doing what it's supposed to do. I'm gonna turn it back off. Only because the music box doesn't have volume because it's a music box and it's loud and the part that's open is facing me. So I'm gonna turn off so we can talk. So when it was flashing, I'm like, and then I started looking at the box. So the box is freaking huge. So it doesn't really fit. I mean, this unit's big, so the box has got to be much larger. But it says multi-action illuminated musical, as well as it had something on here about the lights. Yeah, those move. ISO bass or rose. Because even in the picture, it shows it on and off. Well, supposedly it's on, but the picture is not really turning. But I can't see anywhere where it says the lights are supposed to be static. So I'm going to look online and see if there's any videos to confirm. But it's back together. I mean, minus the two panels. I got to take the screws out and then also glue the bottom plate back on. I'm going to plug its original power supply in now. So all I did was just take a 3.5 millimeter build your own jack. If you've never seen one before, you can buy them on Amazon. You just solder the wires on. It's under the headphone stuff for a mono headphone as an example. And then I soldered on a short pigtail of wire so I could plug it into my machine. And of course I made sure the color code is the same, so it made it easy for everyone watching. Black is the negative, which is the longer part, and positive is the tip, which is the shorter part. And in case you've never seen one of these before and you're still watching this video after like 14 hours of doing this, the negative is the long and the positive is the short pin in the middle. So I'm going to set this up here and we're going to plug in his original that he sent me, and then we're going to do it again. So you get to hear the music one more time. Hey, the lights are on. So the timing circuit is in that chip in that transistor. The transistors was causing it to blink. Now those, I'm not fighting the music with my voice. The three burnt components that I thought were burnt resistors weren't burnt resistors. Those are inductors. They are discolored, probably not from heat. It is possible, most likely from age. I started scraping on them with my fingernails, and I was able to get through the insulation, and then I was able to test them to check. They're not resistors, they're inductors, and that's probably what's causing the lights to pulsate on the tower, because they're hooked up to the transistor, which I thought was a voltage regulator. I looked up the number. So I made some mistakes. It happens, but you have three inductors, a whole bunch of resistors, and you have a big transistor, not a power regulator. So one thing that's needed was a gear, and then all the grease to be replaced because the grease was nasty and hard and acting like concrete. I know when I got it, the lights wouldn't even flash. And that could have been the fact that, I don't know, the wires came free and wrapped themselves around and ripped themselves apart. So it didn't need any parts other than a gear. It is a very moderate repair, meaning it's not as easy as you think. It's also very fragile, being all plastic. I mean, just getting it here, you can see, I'll pull this guy back off. Straight up, come on. There you go. This fence is warped. It's plastic, probably from being in the packaging. So, it's one of those things. Also, I'm going to turn him. I had him too far over. If you have this piece, to take it apart, take off the spire, take off the balloon first. Take this dude off, the guy with the balloons. So remember, balloons and balloons. And take him off. Then cam lock the bush. You can see the teeth. Cam lock it out, and then figure out how to get the screws out. Now, you saw I used this fancy tool. I'm going to use it to put it back together. I got to take the top off to put these panels back in. So that's why I put 2 screws in the bottom, and I haven't screwed the center back together. So I'm going to pull him back off completely since I need to do that. But I just wanted to show you, if he's out of alignment, you just turn him on the peg. Because when I was doing it, the balloons were actually touching the fence. You don't want the balloons touching the fence, so pull it back because the fence doesn't turn. The rest of it does. So I'm going to put him over here for now. Take out the 4 screws in here, take out the 4 screws on the bottom, and then walk it up. And the reason I say walk it up is because you have tension on the 4 posts that hold the green outer ring on. Then you have tension on, well, sorry, there's one other screw too. You have tension on the center hub, and the other piece that you'll have to unscrew once you get the ring off is that bottom center screw. Now, the bottom center screw holds the mechanism in, not the Eiffel Tower shaft. So you need to take that screw out too once you get the top off and out of the way. Careful, it is plastic. These are glass bulbs that are on the side. They're not LEDs. These are actually incandescent bulbs. They're the old school fairy lights before we went to LED. So just be aware you don't want to smash one, because if it burns out, the rest of the string is going to quit. So once you do that, go ahead and set it aside. Take the screw out of the bottom. Then you have those holes in the deck. Get a screwdriver, or this reached, but you need something that has a little bit of length on it. Unscrew the 4 screws, and then you can remove the bottom motor assembly. Then flip it over. There's 4 more screws. Take that apart, and you can separate to where the gearbox is to get to your gears and your motor. So you can clean it, re-grease it, replace the broken gear or gears, replace the burned out motor. Luckily, this motor is marked, and you can get a replacement. It might be a little faster, a little slower. They may not have the same RPM anymore. And the motor for the music box part, which is on this side, where this plate is also replaceable. They are not the same motor. The music box motor is a round barreled motor, and the motor that drives the unit has a flat top and bottom, so it's curved edges and then flat on the top and bottom. It's basically these kind of motors here. So you can see it's flat and then rounded. So they're not interchangeable motors. They are 2 different motors, but both motors have stickers on them that tells you what they are. You can cross-reference them using the World Wide Web and find the correct replacement motor, or the closest one to it, again, because things change. This is so old, it may not have the same RPM anymore. Size and voltage are the important thing. Physical size and the voltage. The motor that's in here is probably rated at 12 volts, which is standard for a lot of miniature motors. They're usually between like 3 and 12. I was testing this motor on my bench at less than 2 just to make sure it spun and it didn't make some odd screaming sound. So, and the other motor is the same way. It is a 9-volt unit. I do think the power supply is underrated for what it is. If you have this and it burns out, the power supply, not this. If it burns out, the replacement power supply, I know this one says a half amp, which is 500 milliamps. I would replace it with 750, preferably 850 or higher. The reason being is my machine, which is relatively accurate, there's always a tolerance, shows the spike 50% over this. Now the spike isn't very long, but there's still a spike. And this, as long as I had it running, is noticeably warmer than the ambient air temperature. And I don't mean that in a bad way, like, oh my god, it's going to set my house on fire. It's not so hot I can't hold it, as you can see. I'm just holding it off center, so I'll drop it onto this. It's just, you can feel it's gotten warm. But it's also been plugged in this entire time. Transformers, when they're plugged in, whether they're used or not, still get warm because it's still converting power in here. There's still magnetic lines moving back and forth. That's why they call it vampire draw or vampiric draw, is because anything that has a power supply, like your cell phone charger, it will always draw power. And if you ever have your electricity balanced in your house, you have to unplug all those things, as an example, so they can test your electrical. And they're not a lot, but it's enough to create heat. Also, same in your car. If you leave your thing plugged in all the time and your car doesn't turn off its cigarette lighters, it will drain your battery for the same reason that this will stay warm when it's plugged into your house. So just some small things to learn. It's usually not that big of a deal. My display is on switches. They're all plugged into the wall, or a power strip, which is plugged into a switch panel, which is then plugged into the wall. So my power supplies I never unplugged, but they're also 2 levels of disconnect before you can turn them on. So, but anyhow, going a little too far into the electrical aspect. But I did see last year a couple of houses burned down, and they attributed it to mini villages. Can't say it's because they overheated power supplies like the one over there, but it could be, overloaded circuits, like 400 houses on 115 amp breaker, so something like that. But anyhow, so this piece is pretty neat. It's not my style, still pretty interesting. It's a little bit of a challenge. I ain't gonna lie, it's kind of a pain at some points. I didn't expect the gear to be such a pain in the butt as it was, and then getting it to line back up and then come apart, the part that swages in, that is really sticky and really tight. But I'm sure there's a reason they designed it like that. Besides self-centering, I'm sure it's also to keep it so it can handle the added torque it needs. I mean, this isn't very heavy, this balloon, a couple ounces, but nonetheless, it's an off-balance rotational mass, so therefore it's going to create torque on that shaft. So it all makes sense. I'm sure there was some engineer that worked on it when they built it so they wouldn't kill anything like power supplies or circuit boards. So, but I'm going to go ahead and put the panels back in, glue on the bows, and put the other 2 screws in. Once I do that, cam lock that down. You saw what it looked like in low light. But other than that pretty much sums up this piece. So now it's just some small busy work to get it back to the way it was when I got it, except the functional part, we made it work. And then I will send it back to its owner, and they can have it for their display again. So thanks for watching this really long repair on the Enesco Eiffel Tower, which is the I Love Paris edition from the Luster Fame Design. Small World of Music by Enesco. It's got like 18 names on the box. And the box says 1992. So I know I said at the beginning of the video, but I couldn't remember. So this thing's 33. She's old, but still looks good. Works again. Send it back to its person, make them happy, put it back on their display. So until the next one, thanks for watching.